All right. Oh, I need to actually start Docker. So let's show what I've been working on. Let's show what I've been working on. Oop. Man, my bitrate. Oh, it's bad for the average when you do that. Okay, so let's have a look. This is a PlayStation 2 emulator, of course. And we have, if I can like resize the window properly. Okay, we have an attempt at drawing some stuff to the screen, and it's kind of working, right? It's kind of working. So I did some refactoring off camera of this, right? I've been doing this all on camera. I sat down and did some refactoring. Where before we were doing some like weird bit hacking mesh stuff. Like we were loading mesh from a file, right? That'll happen before. Now I'm actually doing like a model view projection transformation, moving it from model space into world space, into local space, into screen space. Each vertex in our kind of testing models here. And I'm trying to move them into PlayStation 2 coordinates, but it's not really happening. So let me show you what did work. Let's go over. So this is a cube, okay? And I've set it up while this is like running. Let's get another ST big terminal going on. My terminal is ST, and my big terminal is ST big. Because it is ST, but I have the default font set really big. All right, so if we look at main, I've hooked this up. Right, every frame we're drawing here, after VSync, we're gonna scale up our model instance by 0.01f. I don't really know like what the scale is here, and you can see this is a cube that is slowly getting bigger, but it's getting bigger on a fairly janky scale, right? And there's no fractional part to the floating point numbers that we're working with. So it's only moving in whole pixel units, which is quite evident. It looks a little bit jank. But it's kind of cool, right? Like you can tell this is a cube. It's growing, it's getting bigger. And it's going to keep getting bigger. So what's also interesting about the way this is set up, I think this is in draw.c. If we look at the functions, so these are PS2 SDK functions, right? These come out of the box. This is people have written these. Smarter people than me have written these. And actually, let's pull up the implementation because they're super interesting. ST big. That's not what I wanted. ST big. Okay. It's in EE 3D Math 3D. Source Math 3D. So, vector apply, right? Multiply a vector by a matrix. Some very smart person has written this in assembly, in very efficient assembly, which is using some cool instructions that actually do single instruction multiple data, right? This is cool. And yeah, so like a bunch of stuff has actually been implemented in assembly. I've written functions that do this kind of thing, like bare metal C 3D math, without GLM or CGLM or anything. But I've never actually optimized it to assembly. So this is cool, right? So like this is a function someone's written to calculate vertices. This does like a matrix transformation. It does it for a list of vectors. And this isn't really appropriate for what we're doing, which is unfortunate because this even goes as far as like clipping and yeah, cool stuff like that. So this is really cool. We're using some of this, but not all of this. And the parts we're using the parts we're using are fine. All the parts we're using just exist in like floating point space, but then when you send things through to the PlayStation GPU, they have to be in 16-bit fixed point format with a 4-bit fractional part. At the moment, we're just ignoring the fractional part. The fractional part is always 0, which is why this is not scaling very well. What's also interesting is that these functions, like I don't really know how view screen works, right? But they're taking these ranges like -3 to 3. I'm guessing this is the kind of cube or the kind of like cuboid that we're well, like not a cuboid, like a stretched cube. This defines some kind of bounds, but I'm not really sure what bound it defines. This is our aspect ratio. I may have done this wrong because we seem to be more high than we are wide. I think maybe I want 3/4 for this. So let's do that. 4.0. This might hopefully be... But basically, I'm confused about how our screen matrix gets to a screen without the actual like dimensions of our screen. So that's something to experiment with. That's something to play with. Let's rebuild this. And we get some really fun errors with this. It's all good. Let's see if our cube is a little bit more square now. It looks better. We'll leave that running in the background while we do some other stuff. But yeah, these are real graphics running on a real PlayStation 2, which is really cool. So the problem with the reason that our coordinates don't have any fractional parts, by the way, this actually looks like it's now too stretched in the opposite direction. Very interesting. Maybe our aspect ratio is 1. We've written our own function here for converting into I4, aka 16-bit fixed point. I don't know why PS2 SDK calls it I4, but it does. So that is defined in our draw.h, and we're just taking a number and we're left shifting it 4 bits. That means that the fractional part is going to get... Well, we're going to keep the integer part and wipe out the fractional part. So there's an example from PS2 SDK which does some weird maths like this. I don't really know what this is, and this, for my case, has not worked, which is annoying. So the other thing to try is just using the PS2 SDK definition of F2I4, which is the next thing I'm going to try. So F2I4, it's probably going to complain that, well, let's see. Yeah, this is now too wide. Weird. It's probably going to complain that we don't have F2I4. Yeah, so let's grep. Let's find where it's defined. Draw types.h. So draw.c, draw types. So this is just like mesh.h. Don't know why I was trying to include that very formally. Make run. I need to start this bigger. This looks better already, but let's start you bigger. Or start the camera closer. See, let's keep you at 0. Let's move our camera to like 2, I guess. And it looks like we're actually no closer. So this is one of the things I don't get about how this works, right? If we go into math 3D, hold on, if you just give me 1 second, I might actually just quickly spam advertise. Oh shit, I forgot to, I forgot to screenshot our games as well, thankfully. Sorry, just like context switching back to the Quake for a minute. Apparently I need to report the scores. Thankfully I've got a stream as an archive of that forever. Let me just quickly advertise that I'm doing PS2 dev on all the usual channels. I've been spam advertising around a bit. People don't seem to mind, which is cool. Okay, so what am I doing? I'm looking at math3D source math3d.c, and we're gonna look at the function that sets up. Well, hold on. We're gonna check back in on this fella because he is growing. He's growing. We're also using 66% of the emotion engine. Like this is like 100% is fully maximizing the CPU. We're using like, let's say 70% just for doing all of the transformations necessary for one cube. I don't know how this is so expensive. Surely something has gone wrong here. But anyway, it must be the multiplications we're doing or something. Wolf's mask dill. Hello. Thank you. Sorry, I'm really bad at reading names. It's my curse. But welcome to the stream. Thank you for coming along. This is going to be very exciting. This is a cube. It doesn't look like it yet because it is axis aligned and our camera is axis aligned. But this is a cube We're going to do fun things with it. And it's a growing cube as well. We've rigged up the world's simplest example. We have a mesh instance. We're initializing it to like be size 1, and we're scaling it. We're increasing the size on each frame. Let's also try inst.rotate 0. Let's rotate it around the X axis and see what happens. And let's also rotate it around the Y axis and see what happens. I'm experimenting here. I suspect this won't look good because something's rotating. It's doing something. Holy shit. It looks weird because it's very small, but this is legit. This is legit rotation. Oh, this is exciting. Here it comes. Here comes the cube. I need to start the scale bigger, but it's coming. This is huge. This is huge. Real 3D graphics on a PlayStation 2. Oh, it warms my heart to see. It warms my heart to see. This is obviously not quite correct rotation, I don't think. This might be a case of like gimbal lock weirdness. I don't know how good the rotation handling is here, but it's doing something. So the next step probably is to actually rethink the way we're sending vertices through the system here. You didn't even know about this? Yeah, if you're interested in making stuff for the PlayStation 2, PS2 SDK, you can get it happening. You can get it running pretty easily. I build everything rather out of a Docker image. So there's a Docker image, PS2 dev. I extend that a bit. I add make and bash and a few little tools that can be useful. CDR-Kit for packaging things into ISOs. But yeah, this is a spinny cube running. So this is an emulator. I do want to get a PlayStation 2 in here hooked up, get a capture card and stuff. If you think that sounds interesting, you're welcome to donate and help me finance those kinds of things. But obviously no pressure to do that. But yeah, I am going to be hardware verifying this stuff as I go. I do have a PS2 set up out in the other room, but I want a setup for specifically streaming with a PS2 for this stuff, like just rigged up to run Homebrew, smash it out. Cool. So this is good. This is very satisfying. This is very satisfying to watch. I really like this pattern. I don't know why, but it's good. So at the moment, we're pushing vertices through to our PlayStation 2. Let's get rid of that. I don't care about that. We're pushing vertices through to our PlayStation 2, and let's go new layer. Cool. P. Yeah, sweet. We're pushing vertices through in a very specific format. There we go. Okay. Perfect. So, okay, I'm bored of this. I'm bored of this. I guess there are two problems at the moment, right? One, camera. I'm worried that our camera matrix isn't being set up properly. Two is that we can't really do depth. Excuse my horrific handwriting. At the moment, our vertex format looks like this. So we load, we have a script which pre-processes an object file, a .obj, and it builds a list of vertices in a file. No header or anything, just raw vertex data. Each vertex is going to be 128 bits of pure vertex action. So it's a vector split into 4 components. So this is our vert. So we have X, we have Y, we have Z, and we have room for a W, which is kind of weird. But anyway, we'll live with it. So in other words, we have our vertices and each vertex is one component. We need to change this because we need to be able to pass through color information as well. So am I making a PS2 game? Yes, ultimately. I'm going to make a game that runs on the PlayStation 2. For now, we're just setting up 3D graphics. We're learning about the way the graphic synthesizer works. I've done some of this before. I've not done some of it before. Make something like God of War. That would be amazing. That would also take a very long time. I'm going to set my sights a little bit lower first. I have no experience making like 3D models and stuff. Unfortunately, a lot of the assets will have to be specially made and specially processed to work well in a PS2 and make use of the hardware. But yeah, God of War is an awesome game. My boss at my previous role at my current job actually, like, he worked for THQ for a while, and he knew one of the guys that worked on, he basically wrote the guy he knew wrote the graphics engine for God of War, apparently, which is really cool. Taurus Johnson, thank you so much for the follow. Hugely appreciate it. Always great to see some new faces around here and new people trickling in. Prince of Persia Sands of Time, also a fantastic game. I have no idea how they do the cloth simulation in that game. It looks amazing. It boggles my mind. You can do amazing things with the PlayStation 2. You can do really cool like simulation effects and dynamic geometry, but you need a galaxy brain or a lot of time to do it. So, you know, if I could say like sit down and do this full time for 3 years, I'm sure I can come up with something amazing. I don't have that kind of time. So we're talking about a vertex format, and we're pre-processing object files into just a list of vertices, and then we're copying this directly into a buffer, which we then do our transformation. So we go from floats into the PlayStation 2 integer format, which is a fixed point 16-bit format, right? For each vertex in the thing, we do a fixed transformation. In addition to going from float to fixed point 16, we also do our like model view projection stuff according to where the camera is in the world, where the model is in the world. Eventually, we're going to pass a buffer immediately through to Vector Unit 1, and Vector Unit 1 will do this transform in place. So we're doing this transform in place, right? We're kind of emulating what the vector unit is eventually going to do, even if it's not the most efficient way. And one side effect of that means that we want our vertices in a format where they're just in a straight list and we can do things in place very easily. So our current vertex format is position, and that's it. But to improve our current visualization, we want to make sure that we have color as well, because we will set color, like the color for our vertex, depending on, for now, we're just going to set it based on its depth, and then we'll be able to actually visualize depth and make sure that our transforms are working in a way that makes sense. So in order to do that, we're going to have to change our vertex format. We're going to change our vertex format to have vertex information and color information. So our new vertex format, it's going to be the same kind of thing. Our file is just going to be a list of vertices, but each vertex is now going to be, it's going to have two components, right? It's going to have XYZ, YZ, something, and then it's also going to have color. RGB. Perfect. Am I uploading these videos to YouTube as well? Yes. If you want to check out my YouTube channel, in the description section of my stream, you can find links to my website. My website links to my YouTube. I believe my cards also link to my YouTube. So yeah, these go up there. I'm going to do some like, I guess, more produced videos that talk about this, but these streams are really just kind of like a sounding bed, somewhere for me to experiment, me to learn, while I'm kind of working out like what's going on with the PlayStation 2. One of my friends was a member of the God of War development team. No, one of my friends knows a guy who was a member of the God of War development team. Wolf Mask, thank you so much for the follow. I love it. Love to see it. So, where we're doing our transform at the moment, we're reading in our vector, our vertex position. We're now going to read in this and color. We're going to actually ignore color. We're not going to set anything here. So when this gets read in, it's actually just going to be zeros, like hard-coded. But then when we do our transformation, we will write color information into this vertex. That also means that at the moment, I believe, if I look at this, draw.c, are we mesh.c? We're hard coding our vertex format. So this is like horrible bit hacking. We've got some new people coming in here. So let me say a few quick words about GIF tags. Okay, GIF tags, we interact with the GPU of the PlayStation 2 via the graphics, the GIF, the kind of graphics interface. And we have to hard program special bit values that will tell it what kind of data we're sending to it. Eventually, we will have a nicer abstraction for this. For now, we're just doing manual bits. So our first GIF tag here, this is saying that we're going to send, we're going to be setting one register, and we're going to be doing it twice. And that register is a special register called A and D. That means that we can set other registers. It's a bit weird, it's a bit indirect, but this is telling us that we're going to send through two operations. The first operation sets the primitive register to draw triangles. The second operation sets the color register to a certain color. So what I'm actually going to do here I'm going to commit because I'm about to make some breaking changes. Draw.c, draw.h, if you're interested in the code for this, by the way, it's all going up on GitHub, and it's all, like, the code I write on stream is sorted by branch per stream. So if you want to look at the stream from this date, there will be a branch on GitHub, stream 2021-08-11. Beautiful, beautiful. I believe the Git link is either in the description or you can get to it through my website, which is linked down below. So we've got our new branch. We are going to go into mesh.c, and we're gonna change this. We're gonna get rid of color because we're no longer we're no longer just gonna set color once. We're gonna set it per vertex. So here, now instead of setting, so in this gift tag we set 3 registers, and we set it. We would set in this section, in these bits down here, in these bytes down here. We would set how many loops of these vertices we're doing. So we're setting position 3 times. In other words, we're sending one whole vertex per loop. And so we kind of calculate the number of faces in our mesh. We mask it according to this special format, and we add it on to the end of the number here. So now instead of setting 3 registers in this, all for position, we will modify this to send color, position, color, position, color, and 1 in this case is color, 5 in this case is position. I just know this because I've been doing this for a little while. So now instead of 3, we change this to a 6 because we're now sending 6 register commands rather than 3. Perfect, and everything else stays the same except when it doesn't. VLAN, that is okay. So because I kind of thought this through ahead as well, I can just modify our vertex size and the position offset, I think. Buffer, I'm pretty sure this will work. Weird. Yeah, you had an issue installing in WSL. So I don't really know. When I was doing this on Windows, I was using either virtual machines running Linux or I was using Docker. I'm a big fan of doing this stuff in Docker. Virtual machines, honestly, like my setup is DWM. I'm using ST. I'm doing everything at the terminal. I was running a similar setup to this in a virtual machine, and it ran snappier than Windows did, right? Like you can go so far with virtual machines in Linux, especially if you have disk space to burn. I highly recommend it. I think it's a really good way to work. Docker's worth learning about. Docker is a way to run containers that are like self-contained little, everything but the operating system, I guess. That you can just pull down the Docker image for PS2 Dev, and it has all the stuff you need already in it, and it runs in a self-contained environment. It's really cool. It's really cool. Worth learning about if you're interested in tech stuff. So we've modified our gift tag format. We need to just double check when we do this transform that it's going to be done properly. And essentially what we need to check is stride is based on vertex size. So yeah, so we're calculating vertex size here properly, and all we'd need to do is change vertex size to 2. Position offset is 0. We just need to also know a color offset. So where we define our mesh, we need to come in and say that we also have a color offset. Beautiful. And again, we're just going to hard code this. So this means that this is the first 128 bits. This is the second 128 bits. I'm going to make my own engine. There are no pre-built game engines for PS2. There are some better graphics abstractions. I'm doing graphics very close to the metal because I think that's interesting. There's a library called GSKit, which has already done a lot of this kind of work in a lot of ways. You can just like start pushing some triangles through. Is it like OpenGL? Not really. There is an OpenGL 1.2 wrapper, or like kind of a OpenGL 1.2 port. It's weird because the PlayStation 2 is so different to how OpenGL works. So it's a subset of OpenGL. Someone was playing around with it today. Hold on, there are some performance numbers. the performance was really good, and they're going to get someone to help them optimize it, the Vector Unit 1 code. So they claim, where is it? Let me pull up the image as well. So this is a draw example they had with it. They reckon they were drawing 15 million triangles per second. So, just over 250,000 triangles per frame, which is pretty good for a PlayStation 2, especially for a general purpose abstraction built over this hardware, because the hardware is super finicky and super specific. Okay, so we've made that modification and that should work. And now I'm going to jump into my tool that pre-processes object files, and I'm going to modify it to do more than just output position. And for now, we're going to do the really dumb thing, row append, f, and it'll just be 0, 0, 0, 0, because we're ignoring the color information. Or we're ignoring it from the point of view of, like, we're not setting it to anything. At a model level. We could actually support models with per vertex color, but we're not going to. And we're not going to for a very good reason, because we're going to do a later optimization that I think will make that impossible. Cool. So, if I rerun this tool, conv cube dot, where's my cube object? I think I lost my cube mesh. Hold on. There was a really good open source cube mesh someone had. Cube.obj. Where is it? No. Does someone have a good, like, cube.obj I can just grab? I found such a good... Is this it? Yeah, this is it. This is it. Perfect. Okay, so let's just, like, make sure we actually save that this time. Cube dot... cool. So we've got an obj parser. This just, like, steps through, finds vertices, finds faces, cries if it sees anything else. We don't care about normals and stuff for now. Let's go Python 3 conv cube.obj. Yep, dumps a bunch of binary data out to the console, which is good because we're writing a binary file. I wrote cube. Oh well, that's fine. I can't spell. One thing I'm learning from these streams is that I cannot spell. My spelling is terrible. So cube dot, let's call it cube.bin. If I cube.bin, yeah, that looks good. Okay, so let's move cube.bin 3D test cube.bin. Cool. So now if we come into our main, and then all we should need to do is modify... Oh no, hold on. There is actually one other really silly thing we have to change. We're hard coding this header length, and this is now the wrong length because we've changed the header, which is not good, So our header, it was 4 quad words, and it's now less than 4 quad words. I want to go to draw.c. No, I don't. I want to go to mesh.c. So it is now 1, 2, 3, 4, 5, 6. No, 1. It is now 3, sorry. 1, 2, 3. These are double words, not quad words. So let's actually define this in draw.h. Sorry, just getting a little cheeky message here, I think. It's all good. I can ignore that one. PlayStation 3 or PlayStation Vita. PlayStation 3 is even harder to work with than the PlayStation 2, so I haven't moved on to that. I doubt I would. If anything, I would probably go back to PlayStation 1 and Nintendo 64. That's more into like my childhood, I guess, the stuff I'm like really passionate about. PlayStation 3 and later is a very different phase of my life. Mesh. It's going to be 3. Cool. So we just have this magic number in main, which is a little bit gross. Where is it? It's the number 4 here. Nope. I mean, we've got a few magic numbers around the place, as I'm sure you can notice, but this one in particular is very, very gross. Mesh header size. So this just tells us that when we do our transformation and find our vertices and like move them into, you know, like PlayStation 2 format, whatever, just ignore this much, because this is what actually tells us how much we're drawing, and we can't mess with that. Draw.c. Now we just need to make sure, well, let's uint 32t. So we're going to have 4 uint 32t's in our kind of like color vector, I guess. So we're doing some like weird reinterprets here. It's fine. It's fine. P plus strain, that is... Okay, so all we're going to do here, because we're treating this coming in as just a stream of bytes, so we're reinterpreting this and jumping to the spot that represents a color vector for this vertex. And we want vertex color offset. I have this really weird habit where I try and type color without a U, because I'm used to working with like Americanized code bases, but no, I put color with a U wherever I can, and we're just going to say col 0 equals 0xff. So we're going to draw in red. Actually, no, we're going to draw in green and also equals 0x80. We need to make sure we set alpha as well, otherwise we're going to have a very sad time. I spent about an hour... I spent probably about 2 hours trying to draw triangles and I couldn't. Someone was like, maybe you're just drawing invisible triangles. And I laughed. And then I checked and I was drawing invisible triangles with 0 alpha, which, not fun, not fun. So let's see what happens when we make this. Perfect. I mean, it builds. And then it does nothing. Interesting that it draws like literally like it doesn't even clear the screen. So something has really gone wrong here. Let me see if I can just like reconfigure this window. Sometimes I change this window size and it remembers what I want, and sometimes I change it and it doesn't, which is annoying. Tiling Window Manager really is not friendly with the kind of like display that PCSX2 wants to have. So let's go main.c. Oh, right, I need to go into log. I've got this like toggle because this really spams the ever-loving daylight. It spams the ever-loving daylight out of the PCSX2 logs when it runs. Cool. Oh yeah, I'm not drawing the actual whole buffer anymore, am I? Okay, because again, this was too spammy. Even with that toggle, I still got rid of this. Print buffer. It's really important to be able to like just dump the buffer out so I can investigate it. Yes, sweet. Okay. So we can work from this. So here's our buffer. We want to find where our stuff starts. So this looks like fairly consistent data. We're looking for something with a... So here, this is setting a register with A and D. I'm running emulator, yeah. I want to move towards getting a setup with a PlayStation 2 in here with a capture card. I'm working at it. It's not quite there yet. I'm hoping to get some donations from wonderful people watching this stream to help finance some of that stuff. Obviously, people are under no obligation, but if you do want to consider it and you're enjoying the show and you want to see maybe some more production value and some real hardware verification, do consider... Again, you know, I would be very grateful for anything people were able to offer. I'd probably grab an Elgato HD60S. I hear that works with Linux. Linux compatibility. I'm running everything on Linux now, so Linux compatibility is a big deal. In the short term, I could probably buy like a real cheapo, like $10 one off of eBay, or like, you know, one of those like really janky ones and see if it works, but I don't know if it will. But yeah, my goal isn't to get everything like super high quality right up front. I'd be prepared to, you know, do it piecemeal and do it janky, like get one of those $5 PS2 HDMI dongles, and then eventually upgrade to something like a RetroTink as I go on. That's kind of my plan. That's kind of my plan. PS2 outputs. Yeah, so you need a way to convert the PS2 output to HDMI as well. So you'd need either an upscaler, RetroTink, OSSC, something like that. There are lots of bits. There's lots of things that would be good to have. Okay, so our GIF tag header starts here. We set one register, and this is the primitive register. We're telling it we're drawing triangles. I think they're hit and miss. Yeah, exactly. They're super hit and miss. But unfortunately, the good solutions are like pricey, which isn't great. Okay, so this looks good. We're setting 1.8, which is not correct. This isn't the number of faces in our cube. So we're overrunning this, and our drawer is never properly finishing. That's the problem. So we're calculating the number of faces in our cube wrong. And we just haven't changed it. It's in mesh, sorry, mesh.c. We haven't updated it to deal with the new buffer length. Yeah, so we're just dealing with the buffer length. What we actually need to do is divide by the vertex size as well, I think. So if the buffer length, the vertex is size 1, let's say 16. Let's be smarter than that. Let's say 16 times m vertex size. I think that better represents what we're doing rather than just dividing by 2 again or something. Yeah, so if the vertex size is 3, then each vertex is 3 times longer, so the buffer size gets cut up into smaller and smaller pieces. That is what we want. Make Docker build. Actually, let's do it from this terminal, because this terminal remembers my password. Perfect, so we're drawing. We're not drawing a cube anymore, but we're drawing. Okay, hold on. Let's actually... I don't think we're going to see good output in this buffer, but we'll see what we get. Copy mesh buffer. Okay, so what have we got here? 1515. So here's the start of our GIF tag that's actually drawing the model data. We're expecting color. I see what's happened. We have color first, then position, but we're setting, like, we've told the rasterizer that we're sending color then position. We're actually sending position then color. So we've got to go back into our object creator. We go into conv. Cool. So we put one. Yeah. Nice. So color goes first. Easily fixed. Python 3 conv cube.obj cube.bin. And then we're gonna copy cube.bin back out into 3D test cube.bin. Okay, perfect. And now we just go back into mesh.c, and this is gonna change. We don't have to change anything in the way we're drawing. We just change the offsets when we load the mesh. I'm envisioning eventually this stuff coming from some kind of header, but for now we're just doing it by hand, and I believe our draw abstraction is just going to deal with this, which is really exciting. I think that's cool. I think that kind of abstraction where you can like reorder your vertex format dynamically, I think that's really cool. So this still isn't working, but that's fine. We're fixing bugs. We're gradually fixing bugs. All right, we're looking for our telltale 151515. Here it is. We are having a sign extension here. This screams sign extension. I think this is 0xFF getting sign extended. Maybe. Well, this looks like it's 0x880. Anyway, let's go. Color. FF. Oh no, this looks right. Because this is red, green, blue. No, red, green, blue, alpha. So that looks right. Red, green, blue. Yeah. And then this position looks, this is X, Y, Z. Z is always 2, that's good. Color is fixed, X, Y, Z. So let's let this run for a little bit longer and see what happens. But we've got to get rid of this buffer print because it is just so noisy. Where are we? Print buffer. Oh yeah, we're drawing. We're doing it. That worked. Perfect. Okay, okay. Now we're living. Now we're living. Awesome. That is so exciting. I'm going to turn off logging again, because again, it's just very noisy. And I need a better way to do this. And eventually, I'm going to hook this into, like have a button on the controller or something I can press that'll do it. Here we go. The spinning cube is back. We'll let that grow for a little while. I need to start it bigger. And now we're going to come into draw.c and we're going to think about how we can... So I want to grab out our transformed z coordinate before we do this conversion, and then use that as our depth. Nice. Oh, that feels real good. Small cube success. Yeah, thank you. It feels real good. Let's go float z equals pos 2, and we are gonna color 0 equals 0x AO times hold on, what's our z scale? I don't know what range our z goes in. What's a good way to normalize? It's hard because I don't even know what like range our z might be in. You know, it's a complete unknown. So what if I just say z times let's say z over 10 times, so we'll go as 0x AO, z over 10.0f times this. We need to make sure the float multiplication, the float division happens first, and that should uplift this whole thing into a float, and then we cast it down into an int. And then after we've cast it down into an int, we mask it with 0xff. So this should give us something in the red channel, hopefully. Let's... And this is fine. We get a few warnings, but it's fine. This looks like something's happening. Something is happening according to depth. But it looks like it's a bit binary. It looks like it's a bit on or off, right? Because full red and full green gives you yellow. So this isn't quite right, but it's progress. You can also see here an example of backface culling not really, or like depth ordering, I guess, not really being a thing. Or maybe it is. No, it isn't. Because it looks like the vertices that are closer to the camera are being drawn yellow, but then sometimes the green vertices are being drawn in front of those. Or maybe, I don't know, it's hard to tell what's going on here. It's not quite what we want. But it's progress. It's progress. These are being colored by depth, I believe, right? Because the ones in the same kind of section seem to be getting the same color. So that's good. We're also going to quickly come in, because this is driving me a bit crazy. We're going to come in and we're going to make the initial size bigger. We're going to make it like 4. We're going to make it like 10. I'm pretty sure that will be a better number. But the third component of the vector stays as 1. Yeah, that's a much better size. Okay, perfect. So, what are we thinking? What are we feeling? What are we thinking? So, draw.c, as z seems to be a little bit odd. So what I might actually do, just to be really, really dumb for a minute, is just log the z for every single vertex, because it's not that many vertices. Equals f z, perfect. And then we need to go and turn logging back on with the dumbest manual toggle known to man. And then we're going to run this, and this is going to spam the thing a lot. Again, this doesn't seem right. A spinning cube should not have, like, a spinning cube with a scale of 10, right? Like, this is a cube that goes from 1 to -1. If we scale it to 10, then logically it should stretch from 10 to -10. The Z does not range from 1 to -1. Something has gone very, very wrong here. And I'm guessing it's going to be in the maths that we're not using. Unless it's because we're a very long way away from the camera. There's something fishy about this this camera logic that I don't get. So what if we're like further from the camera? Does this change anything? This should impact Z. But it doesn't. Our Z is exactly the same. So we've moved our camera and our Z hasn't changed. And that stinks. That stinks like something either I don't understand with these abstractions or something has just not, like, outright not worked. Because every frame, we are calling this we're calling update draw matrix. An update draw matrix is creating a world view matrix based on the camera position and rotation. So I guess the other thing is, can we rotate the camera, right? Let's say is it D or DS? It's R. None of the above. Hold on, I forgot already. Camera rot. 0 plus equals 0.1 F. Alright, so if we do a spinny boy, then we're happy. Yeah, okay. That's not quite right. If we're rotating the camera, why is he moving around like that? Where's our camera? We're rotating the camera on one axis. How is it always pointing in the same direction? Like, how is this periodic? He should go completely off the screen. We should just be spinning. He's coming. It's also kind of funny that we're rotating at the same rate we're rotating on the x-axis, so it just completely cancels one of the axes of rotation on the cube. That's kind of cool. It's kind of awesome. Man, okay. This is not correct. This is not freaking correct. Hold on. Did we get... And our depth values are the same. I don't like it. I really don't like it. This feels just so weird and so wrong. Why are these values such nonsense? Like, this is a... Oh, it's because we're... I'm very disappointed in myself. It helps if you actually check after you've multiplied the vector by the matrix. Cool. Okay, so let's redo this. Oof. That has... hello? Why are you angry all of a sudden? SDN. Log. Flip. What? I'm sorry, that just, like... I don't think it matters. Yeah, oh, these are depth values. Here we go. Here we bloody go. So these should be getting closer to the screen, right? Should be getting smaller over time. So we're seeing 400s, we're seeing 100s, we're seeing 400s. It's a bit hard to tell. But I feel like this is about right, because we said the camera is 400 units away, and the cube is growing. So I guess it kind of negates the fact that... oh no, I guess we expect to see like the range increase, right? So it should be going... So here it's 190, here it's 100 to negative... I don't know, I'm still confused by these values. I'm still so confused by these values. So, let's go draw.c. We're dividing by 10 here. That is nowhere near enough, right? We're gonna be maxing this value out every single time. So let's divide by 1,000 instead. And let's see what happens. Now we're getting something. Okay, hold on. I need to stop this camera rotating. That's gonna make me vom. We know the camera's doing something. I might have to write my own math for this. That's fine. So the whole cube has gone a weird shade of green. The whole cube is slightly miscolored. Hold on. I need to work out what I'm doing here. Draw.c. Okay. Here we go. First off, let's make this a weaker value. Cul2 equals 0x0. And then we'll vary the red channel. Okay, so this should increase in color. I've got another thought. What if we just stop rotating for a sec? Stop scaling for a sec, rather. We keep rotating, obviously. Who doesn't love rotation? r.camera pos to negative equals 0.1f. Let's see if we can move the camera closer and observe the change in color. It's very hard to tell. You've got to be very observant. Okay, hold on. I need to make this freaking cube bigger. This is insanity. I don't know why this is so small. Let's make it 100. That's promising, right? That is a cube that is being shaded based on depth. It is also a cube that has many faces that are fighting with each other, and we are also maybe not depth testing at all. Are we? Do we re-enable? I'm pretty sure we enable a depth test. We do, but maybe our Z buffer is misconfigured. Either way, this is some progress, okay? Given what we've seen in the past, this is godly. I'm a freaking genius. You can definitely tell that the closer faces are colored differently, and maybe the color is changing a little. It looks like the color is indeed changing because we've now overflowed our red channel and have gone all the way back to black. So that's cool. So something is happening. Something is working. This is a very exciting day. Okay. The other thing that is actually kind of fun is coloring vertices by X and Y, and then like changing the value based on the depth, right? That gives you a very cool visualization of a cube, but that's something we're going to have to play around with in future streams. This has been me. We've got to spin it. Hold on. I've got to rerun that, okay? I can't end the stream on something clipping so horribly. It still doesn't look good, but we're making progress. And that's all that counts, okay? We're going to get there. We're going to get an amazing 3D engine running on this freaking PlayStation 2. I'm going to validate this on hardware. I might record it on my phone or something and then share it somewhere. This has been a really awesome stream. Thank you, everyone, for tuning in. Very, very enjoyable. We're making progress. We are getting things happening in 3D. It's so exciting. In no time at all, we'll have a little simple game running, and then the sky is the limit. Thank you very much for tuning in. Thank you to everyone who followed. Great to see some new faces hanging around, and be sure to check out my website if you want to follow what I've been doing. I'm Tom, and I'll catch you next time.